Hey, boys and girls, it's Mr. Mac. Today we're wrapping up Module 5 with Lesson 6, which is finding the volume of composed figures. Some of you are like, I have no idea what you're talking about, Mr. Mac. What is a composed figure? Well, if you look at the first example that's given there, that is one of the examples of a composed figure. All it is two right rectangular prisms sitting on top of one another. Okay, so when we look at this picture, we're going to try and remember in our head that really it's just a strange looking figure that's composed of or made up of two boxes sitting on top of one another, right? That's the simplest way to look at it. When we are talking about right rectangular prisms and composed figures like these, the biggest thing we have to remember is any line that is across from one another in a rectangle or a square is going to be equal to the ones that are across, right? So when I look at my example here, I see they want us to know what are these two missing numbers here, all right? If this 5 here is 5 here, I'm looking here and I know that this spot here is going to be a 1 and this line here is going to be a 1 because across from it there's that little 1 foot mark. So if the whole thing is 5 and this is 1 and this is 1, that leaves a 3 here for this space in the middle. So then I know straight across means this is going to be a 3 and this also is going to be a 3. So I know that that missing dimension is going to be a 3. And if this is a 1, directly across from that is a 1. So I would say that is a 1 as well. Okay, so those would be the missing amounts there. So when I'm going to erase some of my work here just so you can see what I'm talking about for the rest of the problem. I'll leave those values. But when I look at drawing a line, I'm going to draw this line straight across here because what that line is going to do is going to clearly show there's a box on top and a box on bottom. So now I want to figure out the length, width, and height for both of them. So I'm going to put on the side here, length, width, height, and I'm going to try and figure out the volume of each of these. Well, let's look at the bottom one. How long is this? It is right here. It's 5 feet long. How wide is it? It is 2 feet wide. And how tall is it? It's 1 foot tall. So if I wanted to find that volume, I would say 5 times 2 is 10, times 1 is 10. So this would be 10 cubic feet or 10 feet with a little cube number there as the exponent. Now, the one on the top is a little bit trickier because we don't have exactly all of those measurements, right? But we do know for the length across the front, we don't see a number there, but across from that is a 3. So that is going to be a 3. My width is right in this spot, but we don't have that. So let's look across. Still don't have it. Look across. Still don't have it. Look across. Still don't have it. You keep going across until you find the width, which is 2 feet. The height is a little bit trickier, so I'm going to go over that right now. If you look in the front of this problem, they're telling you that the height of the whole thing is 2 feet. That's the height of the whole composed figure. We know the bottom one has a height of 1. So if the bottom one has a height of 1 and the total is 2 feet, what is the height of the second figure in our composed figure? It's only going to be 1 again because 1 plus 1 equals 2, and that's the height of the whole figure. So now again, we're going to multiply length, width, and height. 3 times 2 is 6, and then times 1 is 6 again, which is going to again be 6 cubic feet. So when I'm finding the volume of the entire composed figure, we're just going to add them together as 10 plus 6. And that's going to give me 16 cubic feet as the volume of this entire composed figure. So we're definitely going to go over a couple examples for these because they are very involved. And once you get understand the idea that every line that's across from one another on a rectangle or on a square, that they are all equal, your life will be so much easier once you realize that. All right. So again, we have another example here. And the first step, it says is to draw a line to show two different. Now, you could draw lines different ways. It doesn't matter which way you draw them as long as you are knowing where that line is. I like doing it straight across because for me, it's like I'm seeing that they are two separate, one on top and one on bottom. You could also instead draw a line on this one straight down, and it would be two boxes right next to one another. Either way works. It really doesn't matter. It is your preference. But if you're doing one of those examples and you're having a tough time figuring out one of your unknown dimensions, you might want to try and figure out by drawing the line the other way. All right, let's just leave it this way just because that's what I have now, and try and figure out the length, width, and height. So I'm going to put an LWH on this side for the one on the right, and then I'm going to put an LWH over here for the lengths, widths, and height for this side as well. All right, so when I'm doing this, it doesn't matter which one you find first. I'll start on the left over here. I'm looking at the length. Well, already I'm missing this variable for the length, and there's only these spots that they give me the length, and I see nothing. So how can I figure that out? Well, the whole bottom is 16, okay? And I see that this up here says 8, which means this is 8, which means this is 8, okay? If the whole bottom is 16 and this part is 8, we should be able to tell that the missing piece here is also going to be 8. So my length is going to be 8. Okay, my width, again, I'm looking here and I don't see my width, but I know that this width is going to be the same as this width because they're across from one another. And this width is across and this width is across. So the width is also going to be 8. Now my height is given, so that would be a 4. So we got some bigger numbers in this problem than we did in the last one, so we may not be able to do it mentally. 8 times 8 is 64. All right, we multiply that by a 4 here. I get 4 times 4 is 16, carry my 1. 4 times 6 is 24, plus 1 is 25, so I get 256 for this volume. Okay, now on the other side, hopefully, since that one was a little bit of a pain in the behind, hopefully this one will be a little bit faster for us. All right, let's look. We have 8, which is our length, 8, which is our width, and 8, which is our height. So really, that is a perfect cube. Anytime there is 3 dimensions that are all the same, that is going to be a perfect cube. So again, 8 times 8 was 64. I got to multiply that by 8 now. Okay, 8 times 4 is 32. 8 times 6 is 48, plus 3 is 51. I get 512 cubic inches for this one. So now I'm going to add those two together to figure out the volume of this entire composed figure. So I have 512, 256. I'm going to add those up. I get an 8, I get a 6, I get a 7, and that is going to be our answer, 768 inches cubed or cubic inches. All right. Hopefully these examples help you out with today's lesson, guys. See you later on.